Ridge regression. Ridge regression is an example of regularization applied on regression models. In ridge regression, a penalty term is added to the least squares objective function of model when solving the sum of squares of errors to find the parameters of the model, such as the intercept and slopes of the hyperplane. You would have a hyperplane if you have more than two independent variables. Mathematically, this is how it would look like. The sum of squares of error for our regression model, which we call it ridge regression, for finding the parameters b is minimizing this term right here, which is the summation of the squares of the difference between the actual value, the target variable, minus your predicted value, plus the coefficient, the penalty coefficient, alpha, multiplied by the summation of the squares of your parameters. Alpha, the penalty term or penalty coefficient, here is a non-negative value. If alpha is 0, ridge regression becomes the linear regression, our traditional model. The addition of the penalty term is an example of regularization to avoid overfitting by reducing the complexity of the model. The impact of the regularization is controlled by the penalty coefficient alpha value. Higher values of alpha enforce more regularization and would yield simpler models by lowering the values of coefficient, but not zeroing them. Therefore, ridge regression will not get rid of irrelevant features, but rather minimize their impact. So higher value of alpha would actually make, because we want to minimize this term, so to minimize this term, we need to minimize this multiplication. And if you have high values of alpha, the model would rather to have smaller values of the parameters beta, b, which would make the model more simpler rather than more complex. When should we use ridge regression? When the sample sizes are relatively small, for example, because of not having enough data, ridge regression can improve predictions by reducing the variability or the variance by making the model less sensitive to training dataset. We can actually use and work with ridge regression in Scikit-Learn. From Scikit-Learn, the linear module, we can import the ridge regression model, and then you can define your ridge regression model and specify the value of the coefficient alpha, the penalty term. So when should we use ridge regression? When there are, for example, many features that have a small or medium size effects. Lasso regression. Lasso regression is another type of regularized linear regression which uses a different penalty function than the ridge function. Instead of the squaring, it uses the absolute value. Let's see. When we are trying to find the parameters of the regression model using the sum of the squares of error, the parameter b, we want to minimize this term. So the first term is similar. That's the summation of the squares of the difference between the actual value and the predictive value, which is the error, plus this term. This is the penalty term or the regularization term. In lasso regression, the alpha, the coefficient penalty, is multiplied by the summation of the absolute value of the coefficients or the slopes in your model. Unlike the ridge regression, which was using the squared of the parameters. This penalty term, penalty function, can enforce the regression coefficients or the slopes in your model to become 0 for the least influential feature variables in your data, which acts kind of like a feature selection method. We can use the lasso regression available in Scikit-Learn. So from Scikit-Learn, the linear module, we can import Lasso, and then you can create your own model or your own Lasso models and then specify the value of the penalty term alpha. When should we use a lasso regression model? Unlike the ridge regression, lasso can actually force the coefficients of irrelevant features to become zero. So when there are few features in your dataset that have medium to large impact or effect on the target value, you can use lasso regression.